All right, today is fractional exponents. Fractional exponents, so you're going to be able to evaluate them, write expressions, excuse me, with fractional exponents, and write them without. So to evaluate, you're simply going to put this in your calculator. So I know you don't have a calculator right now, but you're just going to put 16 to the, and then in parentheses, 1/2 power. 16 to the 1/2 power is 4. Okay, same deal with this one. 5 times 81. Oh, that's an 81. To the, and then 1 divided by 4. So the deal is make sure when you put parentheses around your fractions. So that is going to be 20. This one is going to be 1/25. This is a little weird because you don't have it, but this is going to be 1,000. 19, I believe, or 49, something like that. And then this is going to be 1/2. So you simply put this in your calculator. I don't think that's right, but you put them in your calculator and you work it out. Now you probably can do it in your phones. Probably does also work. So what you might not know is that when you have a fraction as an exponent, it's the same as having a radical. So it's basically a shortcut way of writing a radical expression. So notice there is an exponent inside with the x. Now sometimes this can be written like this, with parentheses, and writing the a here. Those mean the exact same thing. This and this, okay, mean the exact same thing. But we generally mean this is inside because it's going with what's inside. And this is outside, and that's called an index. So this one right here is called an index for the radical. So normally we're used to it being that right there, having nothing there. Okay, but it means something, and we're going to go over that in just a second. So if we were rewriting this, I have no idea what just happened. When you're rewriting this, the top one is the one that's going to be inside, and the bottom one is the one that's outside. So it goes in, out. So if it's on top, it went inside. If it was on the bottom, it goes outside, or it's called the index. Okay, rewrite without fractional exponents. So the way that we do this one is you're literally just rewriting it. So you have a square root. This 2 goes here, and the 3 goes inside. That 3 is the base. So this one is outside, and this is inside. In, out. Now what's interesting is this is a square root. So we're used to not seeing the 2 there. So it's the exact same thing to write this. So nothing written here means it's actually a 2. We don't have one root. The first root that we have is a square. So the square root goes, we know if there's nothing there, it's a 2. And we know if there's nothing there, it's a 1, because that's just a regular exponent. So the rest of these, you put a 6. This is in. This is out. That's all. In on the top, out there. So I could rewrite this one. So we know this is square root. So rewriting this, it would be just 6 to the 5th, because we don't need the 2 there. It's understood. Same deal with this one. This is 25x squared y. We write a radical, inside, outside. Now we could, anything to the first power here is itself, so we could write without it also. So to the 1/4, we rewrite this. The 4 goes here, and then this is 16, a to the 5th, b to the 6th. So this thing right here is all raised to the first power, but anything to the first is itself. With this one here, this is just like when we did 0 or negatives as exponents. This is the only one being raised to the 2/3 power. There are no parentheses here. So that means the 5x to the 5th is on the outside. Then we have the radical, and then this is inside. on the y. So the y is the only thing inside the radical. The 2 goes inside, the 3 goes outside. Just with notation, you just have to be careful and you know, make sure that, oops, sorry, you know, the 5 and the 3 are separate, and you can tell that the 3 is the index. All right, rewriting this one, I don't know where the number went, but it's 2x. Outside goes a 2, inside is a 1. So then this is just the square root of 2x. This one here, we know this negative is not being raised to the 1/2 power, so the negative is outside. And remember, we're good, because here this is 2, so that should go here, but we know that's understood, and the 1 goes there. The big deal about this one is the negative is not being raised to the 1/2 power, so it stays outside the radical. Going the other way, rewrite with fractional exponents. Same idea, you're just going backwards. I like to do these as an entire entity here, so that means that this is in parentheses, so I know that's a 1. There's nothing here, so I know it's a 2. So I just, in parentheses, x squared y to the 5th, I just 1/2. Remember, that goes on the top, bottom. This is in, out. Now you could do this separately. You can distribute that 1/2 in, and you would get x to the 1st power, y to the 5/2. So just doing a little math might be necessary. This one here, a, 5 is on the inside, so it goes on top, 7 goes on the bottom. Nothing much I can do there. Right? I think this is the last one. I don't know. I get confused. So remember, there's nothing written here, so it is a 2. So then I do 5ab to the 4th. That whole thing is being raised with those 2. So 5 is on the top, and the 2 is on the bottom. You know, you just have to play with it. And then you can distribute if you want here, but unnecessary at this point. So here, 4 is on the outside. This whole thing should be in parentheses. So this is raised to the 1st power. So it's 16 to the 1/4. Well, let's do it this way. So it's 16, a to the 5th, b to the 6th. And this is top and bottom. Now you can distribute here. So let's just do that because it's fun. So remember, this has an exponent of 1, and power to a power we multiply. So it's 16 to the 1/4, a to the 5/4, b to the 6/4. Just multiplying. Remember, each one of these is a fraction itself. Multiplying fractions is no problem. Multiply the tops and multiply the bottoms. So then we can evaluate this. You don't have a calculator, but you got to trust me that it's a 2. And then a to the 5/4, well, that's just 5/4. And b to the 6/4 would be 3/2. You can just reduce that. Distribute that 2 in, and we get 8, a to the 5/4, b to the 3/2. That is so exciting. All right, have a good day.